section 10.4 part 2 is going to finish up hyperbolas. We're going to be looking at asymptotes. We're going to be looking at what their equations are. We're going to determine equations of the asymptotes from the equation of a hyperbola. And we're going to also kind of do the opposite. So if we're given the equation of the asymptote and some other information, can we actually determine what the overall hyperbola equation or graph will look like? So to start out, I want to jump right into an example. We're asked to graph the hyperbola below, and then we want to find the equations of the two asymptotes. And we can find the equations using, they're straight lines, so we can use different methods of writing the straight line. In this case, we're going to use point-slope form. So let's go ahead and graph our hyperbola to start out. We know that a for hyperbolas always goes with the first positive squared term. So in this case, a squared is 9, which means a is 3. B squared would be 16, which means b is equal to 4. And because the x term comes first, this is going to be a horizontal opening hyperbola, so a horizontal transverse axis. We can also identify what our center is. In this case, our center is 1, 2. So let's start by graphing our center, 1, 2. And then we're going to make our little AB dotted box so that we can graph our hyperbola. So A is going in the x direction, so we go 3 to the right, and we go 3 to the left. Those would be our vertices. And then also from the center, we're going to go up 4, and we're going to go down 4. And now I can draw my little dotted line for my box. Okay. So if you remember when we're graphing our hyperbolas, we want to draw our asymptotes connecting the diagonals of our box here. And notice that those go right through the center. Okay. And if I were to graph my hyperbola, I'll do that in blue. I start at my vertices, and I have the curve approach both asymptotes. Just like that. Okay? All right, so looking at those green lines, those asymptotes, I want to determine what the equation is. So just recall that we have the point slope form of a line looks like y minus y1 equals m times the quantity x minus x1. All right, so we need two things. Number one, we need a point, x1, y1, that's on our line. In this case, for both of our asymptotes, they go through the center, so we can use the center as our point x1, y1. So 1, 2 is our point. We also need a slope, m. So to find the slope, I'm going to look on my graph, and I want to figure out, well, what's my rise and what's my run? So in this case, my rise from the center is that b value, and my run over is my a value. So my slope is b divided by a. Okay? In this case, we're going to get 4 over 3, 4/3. All right? So when I'm writing the equation of the asymptote, I'll get y minus y1, which is 2, y minus 2, equals m. So that's 4/3 times the quantity, x minus x1, which is h. All right? And that is the equation of the asymptote. Now, typically, equations are y equals, so we could add 2, bring that to the other side. And because there's two different asymptotes, the only difference is the slope. So here, for the other asymptote, our slope, we went negative in the negative direction, so it'd still be over a, but it's just negative. So in this case, I can just put plus or minus with my equation to account for both of those asymptotes. All right? Now, on the next slide, we have the two general forms of our equation with h's, k's, a's, and b's. And you can see from our example right above that if we plugged in our hk values and our b and our a values, we would get exactly what we got doing it by hand. So now that we know how to do it by hand, we can just have these equations in front of us and just kind of fill in information, and then you don't have to rederive the equation. Okay, so we've got horizontal transverse axis and vertical transverse axis. The only difference is when you make that AB box, for the horizontal, it's B over A. For the vertical, it's A over B. Otherwise, the equations are exactly the same. All right, so we got two examples here. Let's identify what point we're going to use for HK. For our first example, HK is 0, -3. A is equal to 2, and B is equal to 5. So we can fill all that information in. We're going to get, well, again, this is a horizontal ellipse because x squared comes first. Sorry, horizontal hyperbola, I should say. X squared term comes first, so I'm going to use the equation directly above this, and I get y equals k, so -3, plus or minus b divided by a, so 5/2, times parentheses x minus 0. So that would be the equation of my two asymptotes. The next ellipse that we see is a vertical. I keep calling them ellipses. The next hyperbola is vertical because our y minus 1 squared term is first. In this case, we have a little more work to do because we've got some fractions to work with. So if a squared is 4/9, a is the square root of 4/9, so we get 2/3. Similarly, b is the square root of 16/49, so b equals 4/7. Now with our vertical hyperbolas, our equation is y equals k plus or minus a over b. So I want to find out what is a over b. Well, it's going to be 2/3. Oops. Try that again. It's going to be 2/3 divided by 4/7. So remember, if we're dividing two fractions, I can multiply by the reciprocal, 2/3 times 7/4, which will reduce to 7/6. Okay, so now we can fill in what we know. Our center, HK H goes with x, k goes with y. So h is -2, and k is 1. So we've got y equals k, so 1, plus or minus 7/6 times the quantity x plus 2. It's a little bit hard to read. X plus, my board's off balance. Well, you guys get it, x plus 2. Here, I'll write it over on the left here. Y equals 1 plus or minus 7/6 times x plus 2. Okay. So the last two examples, examples 4 and 5, we're given different information. We're asked to come up with the actual equation. So example 4 says we have vertices 3, -5, and 3, 1. This would be a vertical hyperbola. And you might ask, how do I know that? Well, I'm looking at my vertices over here. I've got our y values are changing, which means the vertices are directly above one another. So it's a vertical hyperbola. I also notice that my center is the midpoint. So it's 3 is the x value, and the average of those y values would give me the center right in the middle. So -5 plus 1 is -4. Divided by 2 will give me a center value of -2. Okay, so I know that. Now I also have my information about what the asymptotes are. So y equals 2x minus 8, and y equals -2x plus 4. So in general, we can see that m is equal to plus or minus 2 in this case. So 2 and -2. With a vertical hyperbola, our equation is y equals k plus or minus a over b times x minus h. So I'm going to set my slope, m, equal to a over b. So if 2 equals a over b, I need to find out what those values are. All right. I ignored a little bit of information before. Knowing the center and the vertices, I can find my a value. So in this case, going from -2 to -5 at the distance of 3. So a is equal to 3. I'm going to plug that in over on the left side here. And I get 2 equals 3 over b. So now I can solve for b. I get 2b equals 3. So b is 3 over 2. So we know a. We know the center. We know b. And we know it's vertical. That's all that you need to come up with an equation. So the final equation, being vertical, we'll start with y. So we'll get y plus 2 squared over a squared, which would be 9. And then we're going to subtract x minus 3, quantity squared, over b squared. In this case, that's going to be 3 squared over 2 squared, so 9/4, always equal to 1. So there's our final equation. And our last example, same process, different information. So vertices and asymptotes, actually that's the same information, just a little different process. Our vertices are plus or minus 1 for the x value. So the x values are changing. That means that it's a horizontal hyperbola. It also tells me that a is equal to 1. And whenever your vertices are equally centered, that means that your center value is 0. So plus or minus 1 is 1 in either direction from the origin. So here we have 0, 0 as our center. So our slope is 2 in this case. M equals 2. Now because it's a horizontal hyperbola, the slope should be equal to b over a. So a is 1. I get 2 equals b over 1. So b is just 2. Okay? We know a, we know b, we know the center. We have everything we need. So the final equation is going to be x squared over a squared, which is 1, minus y squared over b squared, which is 4, equals 1. So not too tricky. It's really just applying the slope from the asymptote to solve for the remaining a or b value, depending on what you know. Okay? So there's one final problem for you to try. Given the foci and the length of the transverse axis, you're asked to find the standard form equation and also find what the equation of the asymptotes are. So go ahead and give that a shot and bring that to class with you.